Section 2.1 talks about quadratic functions and models. So in chapter 1, what we learned how to fit a linear model. Now in this chapter, what we want to talk about is how to construct models that use nonlinear functions. So in other words, we want to talk about degree 2 functions. Do you know what I mean by degree 2 functions? What do I mean by degree 2 functions? That means you see a squared in the exponent for an x. Exactly. So now we want to construct models that use quadratic functions. So let's start out with the definition. A quadratic, let's use red. Erase this. A quadratic function of the variable x is a function that can be written in the form f of x equals ax squared plus bx plus c, or y is equal to ax squared plus bx plus c. So you can use f of x equals or y equals. And here, a, b, and c are fixed numbers with a not equal to 0. Okay? So now let's look at an example here. So given f of x equals negative 3x squared plus 3x minus 1, given that we have that f of x is equal to this, state the values of a, b, and c from the quadratic function, and then let's use that to calculate f of a plus h. Okay? So what is a here for us? Talk loud. Negative 3. Excellent. What's B? 3. Good. What's C? Negative 1. So now we want to find f of a plus h. Okay? Here we're not going to use a is equal to negative 3. We just want to find f of a plus h. So in other words, I can say find f of x plus h. Do you like x better? Yes? No? Okay, so I'm going to say here, find f of x plus h. Okay? So what we're going to do for f of x plus h, now we're going to substitute in x plus h where there's an x here. Are we on the same page? All right, let's do it. So that means we have negative 3 times the quantity x plus h squared plus 3 times the quantity x plus h minus 1. How do we find x plus h quantity squared? Use the FOIL method. Very good. When you use the FOIL method, what do you get? Talk loud.
X squared plus h squared plus xh. Yeah.
Part of it.
2xh.
2xh plus h squared. Very good. So that's what you get when you square x plus h. Then you have plus 3 times the quantity x plus h minus 1. Now distribute. Distribute your negative 3. What do you have? Go ahead. Negative 3x squared. Good. Good. Mm-hmm. Minus 1. Very good. That's it. What questions do you have? Okay, so that's an example of a quadratic function. And now what we want to do is we want to talk about the graphs of quadratic functions. Okay, let's talk about the graphs of quadratic functions. Has to cover your nose. Okay, now the graph of f of x equals ax squared plus bx plus c, where a is non-zero. The graph of this function, quadratic function, is a, do you remember? Parabola. Very good. It's a parabola. If A is positive, the graph opens upward and is called concave upward or up. Very good. If A is negative, the graph opens downward and is called what? Concave down. Good. Or concave downward, whichever one. Okay, so for example, when A is greater than 0, your graph would look like that. So this is when A is positive and it is concave upward or up. And then when A is negative, your graph is concave down or concave downward. Okay? This point here, I'll do it in blue. Okay. This point there, do you remember what that's called? Say it loud. Say it again. I can't hear you. Vertex. Good. It's called your vertex. Sorry, I couldn't hear you all the way. It's called your vertex. Very good. So the vertex is the highest or the lowest point of the parabola. So in this case, whenever the graph is concave down, you pick up, is that the highest or lowest? Highest, good. Whenever it's concave up, you pick up a lowest one, okay? That concept will come in handy again soon. The vertex is the highest or lowest point of the parabola, and to find it, you use the following. It's negative b over 2a, comma, f of negative b over 2a, meaning you find negative b over 2a and then substitute it into your function to find your y value, okay? The a and the b come from the standard form for your quadratic equation or quadratic function, okay? Notice that a is not 0, okay? Now, we talked about y-intercepts before. Let's talk about our x-intercept. The x-intercept, it's possible for you to have more than one. The x-intercept is where the graph crosses the x-axis. The x-intercept is where the graph crosses the x-axis. To find them, or to find them, you set y equal to 0, and then you solve for x. Solving for x, you can alternatively use factoring, or you can use the quadratic formula. Remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is how you will typically find your x-intercept or x-intercepts. Got it? All right. Another term that comes in handy that you will also need to use eventually is that of the discriminant. The discriminant is given by b squared minus 4ac. So in other words, it's what's underneath the radical in the quadratic formula. Okay? Things to note. If the discriminant is positive, that means you have two x-intercepts. If the discriminant is equal to 0, then there's a single x-intercept, and that's going to occur at your vertex. And if the discriminant is negative, then there are no x-intercepts. So your discriminant is useful to help you to determine how many x-intercepts you have, or if you have any at all. Okay, so again, if it's positive, you have two x-intercepts. If it's 0, there's a single x-intercept at the vertex. And if it's negative, there are no x-intercepts. Okay, now, parabolas are symmetric with respect to the line through the vertex. The line, remember your vertex is given by x equals negative b over 2a and comma f of negative b over 2a. Remember I gave you an example where I gave you a point and I asked you to tell me the vertical line through that point, the equation of the vertical line? This is the same thing that I'm asking. Parabolas are symmetric with respect to the line through the vertex. That means x is equal to what here? X equals what here? For this, what does x equal? Yes. Very good. Negative b over 2a. Very good. Okay, so now let's look at example 2. Example 2, we're given the function f of x equals negative x squared minus x. I want us to find the coordinates of the vertex, find the y-intercept, find the x-intercepts if there are any, and then sketch the graph. You want a couple minutes to try it? Okay, go for it. We need to find the coordinates of the vertex. So to find the coordinates of the vertex, we need to identify a and b here, right? What's a for us? No, a is not negative x squared. A is the coefficient of x squared. So a is negative 1. Good. What's b? B is also negative 1. So the coordinates, remember, we find using this here. We find the coordinates of the vertex. So negative b over 2a gives us negative 1 over 2 times negative 1, comma, f of that which means negative times negative 1 is 1, divided by 2 times negative 1 gives us a negative 1/2, right? So our coordinates will be negative 1/2, comma, f of negative 1/2. F of negative 1/2, you have to substitute negative 1/2 in here. Okay? So f of negative 1/2 is equal to, now we're finding this, f of negative 1/2 is equal to negative times negative 1/2 squared minus a negative 1/2. So that gives us negative 1/2 squared is what?
1/2.
Nope. Negative 1/2 times negative 1/2 is positive 1/4, but there's a negative hanging on the outside, so you get negative 1/4 plus 1/2. Negative 1/4 plus 1/2. 1/2 is also 2 over 4. Negative 1/4 plus 2 over 4 gives us what? Positive 1/4. Good. So that means that our vertex, the coordinates are negative 1/2, comma, 1/4. That 1/4 comes from there. Okay? So we can go ahead and plot that. Let's say that's negative 1/2. This, let's say, is 1/4. So we can plot that. Let me ask you, is this parabola, is the graph going to be concave up or concave down? Concave down. Why? Because it's what? Because what? A is less than 0. Good. A is negative, which means it's less than 0, which means our parabola is going to face down. Okay? So, how do we find the y-intercept? What do? We set x equal to 0. So we find f of 0. What's f of 0? 0. No fun. So we know that our y-intercept is the origin. That's our y-intercept. And now we have to find our x-intercepts if there are any. You can find this by factoring or using the quadratic formula, whichever one you want to use. This function is not too difficult to factor, so I will write it down this way, but again, you can try the other method. This is equal to 0. These both have a negative x in common. Factor it out. That leaves you with the quantity x plus 1. So now that gives you, when you're multiplying two quantities and that's equal to 0, that means either negative x is equal to 0 or x plus 1 is equal to 0. That, in the case where negative x equals 0, that means x equals 0. If you have x plus 1 equals 0, that means, let me get off that screen, that means x equals what? Good. So your x-intercepts are the origin and negative 1, 0. So this point here. So then you sketch your graph. That's it. What questions do you have? What questions do you have? Okay. The revenue resulting from one or more business transactions is the total payment that's received. Hence, if Q units of some item are sold at P dollars per unit, then the revenue is equal to your price, P, times your quantity, Q. For the demand function Q equals negative 3P plus 300, let's find the following. A, let's express the total revenue, R, as a function of the price P per item. So here, R, remember R is equal to P times Q. So it's P, we know what Q is. Q is negative 3P plus 300, and that's a negative here. So distribute your P, that gives you negative 3P squared plus 300. That's part A. Part B, go ahead.
Wouldn't it be plus 300p?
Oh, yes, absolutely, not plus 300, plus 300p, right? Because you have to distribute your p to both terms. Good, very good, right? Does that make sense? Okay, good. Now, part B, we have to find the price P that maximizes the revenue. How can we find the price that P that maximizes the revenue? Think about everything that we just learned. Yes?
Would we start by getting P alone in the function dividing by Q?
No. Other? Yes? You have to raise your hand higher. The chair is blocking you, but go ahead.
Find like the vertex of this equation.
Why would you want to find the vertex?
Because that tells you either the minimum or the maximum.
That tells you the minimum or the maximum. In this case, do you have a minimum or a maximum?
Maximum.
Why do you have a maximum?
The equation says
The equation says it, yes. But what's another way you can identify it? Yes? It's a negative A. This coefficient of P squared is negative, which means your graph is going to be concave down, good, which means you're going to pick up a maximum. So if you find the price P that, when you find the price P that maximizes the revenue, that means you're looking for the X value where you get your maximum. So you're looking for the X coordinate of your vertex. So that's given by negative B over 2A. Negative B over 2A. What is B? 300. So negative 300 divided by 2A. What's A for us? Good. So we get negative 300 divided by negative 6. That gives us what? $50. Good. That's the price P that maximizes the revenue. And now we want to sketch the graph of the function from part A. We've already really done that, but we know that the price P that maximizes the revenue is 50. So we know that we get our max at 50. And that's a sketch of the graph. Okay? What questions do you have? Yes?
Why don't we have to find like the y of the, like the f of negative 0 to
Because you're only, for part B,
Yes.
because you're only asked to find the price that maximizes the revenue. You're not asking what value you get after that. You're asking to find the price that maximizes the revenue. So you're asking for your input. In other words, your X value.
Thank you.
You're welcome. Does that make sense? What other questions do you have? Okay, let's go ahead and finish this up. Our last example for quadratic functions. Crude oil production by Pemex, Mexico's national oil company, for 2008 to 2013 could be approximated by P of T equals 0.017 T squared minus 0.4 T plus 5.23 million barrels per day, where T is greater than or equal to 8 but less than or equal to 13, and T is the time in years since the start of 2000. Okay? According to our model, so according to this function, approximately when was oil production by Pemex least? So we need to round the answer to the nearest 2 digits. So when was it least means we need to, go ahead.
The vertex.
We need to find the vertex again, right? Because notice that this A is greater than 0, so your graph is going to be concave up, which means you can find the X value of your vertex, and that will give you the least. Okay? So our B is negative 0.04, so we have negative times negative 0.4 divided by 2 times A, which is 0.017. If you enter that, if you simplify this, you have 0.4 divided by 0.034, and you enter that into your calculators. Wavy equals means approximately, you get 11.76, which means, to interpret that, it says according to the model, approximately when was oil production by Pemex least? So about, go ahead.
2012.
Not quite. It's in, because it's 11.76, you're still, when you're talking about years, it's 2011, but about 3/4 of the way through 2011. So good. So about 3/4 of the way through 2011. And then I'm going to ask, what was the oil production at that time? So when I ask you what's the oil production at that time, what do you have to do with what you found in A? Plug it into your original equation, which is P of T. So for this problem, or this part of the example, you have to find P of 11.76. That's equal to 0.017 times 11.76 squared minus 0.4 times 11.76 plus 5.23. You enter that into your calculators and you will get approximately 2.9 million barrels per day. That's a lot of oil. Okay? So that is section 2.1. Have a good rest of your day, and I will see you on Thursday.